Okay, I am Mr. Shrum, and I am back again with some Science 1 tutorials. And today we're going to look at the interactions of light with matter. And the objective is to use models, and we're going to use these models to describe the interactions of light and matter. So let's jump into the content. So for a warm-up, well, unanswered, a student is experimenting with light and color. She has lights that emit one color at a time and filters that allow one color of light through them. She shines a red light on a yellow filter. What do you think she sees when she looks at the light? All right, so we have a light being shown, shines a red light, and then we have this yellow filter. What do you think she sees when she looks at the light? Yellow light, red light, orange light, no light. And we have no light because that filter is absorbing all colors except its own color. It allows a light that's not absorbed to pass through. The colored light is red and the filter is yellow. So that filter absorbs everything but yellow. So no light passes through the filter. So this object absorbs everything but yellow. And since this light is not yellow, that also gets absorbed, okay? And we'll look into that in the next few slides. That's the video you can watch on your own. And then we get into light and color. So asking people what their favorite color is will yield a lot of different answers from different people. There are so many colors around us, and when we describe an object, one of the first things we mention is its color. We talk about yellow sunflowers or green leaves. It's just how we try to identify things around us. We use our sight to know what's in our surroundings. One aspect of sight is our ability to see colors. Now, colors are a part of visible light. Light meaning all wavelengths of electromagnetic radiation. The specific wavelengths that enable sight. So, what's color? Complete the following activity. And this activity has a simulation, a color vision simulation. And once you mess around with that, you can go through these parts, follow the instructions, and then answer the questions. So you can add bulbs and filters, and it asks you why light passes through some and then why it doesn't through others. But we'll get into that in the next few slides. Visible light passes through clear glass, but not through wood. Clear glass is a transparent material. Wood is opaque. And opaque means not transparent. That's all you need to know for now. Visible white light has 7 different colors. And when it strikes an opaque material, the colors can bounce off or be absorbed. Light bouncing off an object is called reflection. So this here is a reflection. Images 1, 2, and 3 show examples of absorption and reflection. So we have reflection, absorption, complete reflection, and then a mix. So like we said with that filter, whatever color the surface is, that's the light that is getting reflected. Therefore, we can see it. But everything else gets absorbed besides what we see. If red light is reflected and the other colors are absorbed, we see a red object. Often an object doesn't reflect any light, like 2. It absorbs all the colors, and that's why they appear black. Because light is a form of energy. When objects absorb light, they also become warmer. We see colors reflecting from objects, and we also see colors when light is emitted from a source. Now, in that simulation before, if you use that simulation, we saw flashlight bulbs that emitted light of different colors. In the image, you see these stage lights, and they're shining colored light on a drum set, a drum kit. So we have orange, yellow, bluish, pinkish, green, purpley colors, all shining down. And an object that emits light is called a luminous object. The sun, the stars, and even lights, like a porch light, is luminous. They're emitting their own light. They're not just reflecting it. Most objects aren't luminous. They only reflect light that is falling on them. A range of wavelengths. Each color of visible light has a different wavelength and frequency. This situation is true for both reflected light and emitted light. If all wavelengths of light are present, the waves are mixed together and we see white light. But you can also split that white light into its component colors by using this glass prism as a pyramid, triangular shaped 3D object. When white light passes through, it separates them depending on their wavelength. Each color moves at a different speed, and that results in the separation of colors. As shown in the image, these colors are violet, indigo, blue, green, yellow, orange, and red. This list is in order of increasing wavelength. So we have violet having the shortest, and then red being the color with the longest wavelength. The range of colors in white light is called the visible light spectrum. And that's the range that we can see when light of mixed wavelength is separated. Now, this wavelength of light is part of a larger spectrum called the electromagnetic spectrum. That includes different kinds of electromagnetic waves. And these electromagnetic waves, made of moving electric and magnetic force fields, that does not require matter to travel. These waves interact with matter. The absorption and reflection of visible light are 2 examples of interactions. So, this question. A light source emits white light. A red colored filter is fitted over the light. What color will a person looking at the filtered light see? It will see red light. A light source emits white light. A red colored filter is fitted over the light. What color will a person looking at the filtered light see? Red light. A light source emits white light. White light is made of 7 different colors, and red is one of them. So when this white light passes through a red filter, the filter will absorb everything but red. Only red light will pass through, and that's what you can see. Okay? Well, hopefully you didn't see that. But a person sees a purple flower at a florist shop. What's true about the purple flower? It absorbs all wavelengths of light except purple. Sounds right. It absorbs purple light. Well, we can see a purple flower, so purple is not being absorbed, it's being reflected. It emits purple light. It's not a luminous object, as in meaning that that flower is not making its own light. It's only reflecting light. So it's not emitting light, it's reflecting. So it's reflecting purple light and absorbing everything but that purple light. There's an explanation. You can read that, pause it. I'll move on for now. Now, getting into mirrors. We learned that when light waves strike an opaque object, some waves are actually absorbed while others are reflected. When light waves strike a rough or uneven surface, the reflected light waves bounce off in all types of random directions. When light waves strike a smooth surface, the light waves keep their alignment. A mirror is an example of a smooth surface. In a mirror, light waves are reflected in such a way that we can see an image of an object. The light waves travel from the object to the mirror to our eyes. And this image is called a virtual image. Watch the video on the next screen to learn how mirrors are capable of actually tricking your eyes. So you can watch this video on your own. But in it, we have these sort of optical illusions where things may appear to be closer than they appear, but honestly, it's just a mirror. But some of these are fun. And they explain why, what's going on. They even use lasers too. But yeah, that's a fun video. Just go check it out. And then when we look into a mirror, what's true about the image we see? The image is real? Well, in a way. The image is virtual. That's a better way of putting it. The image and the person forming the image aren't located in the same place. This is true. That image appears in a different place than the body you are currently existing in. And the light forming the image first reflects from the person and then from the mirror. So in this explanation, when we look into a mirror, we see our image, which looks exactly like us, but it's not real. So don't think of real as in it exists, but think of it as something you can touch or something that would exist without a mirror being there. The image appears to be behind the mirror, but it's actually not there. It's just reflected light. We can see our image when the reflected rays are bouncing away from us, and those get reflected by the mirror. So we are reflecting light off of our body, and then that light is reflected off of the mirror, and that's why it appears like us. But it's a virtual image. It's only reflected light. And I think that's where I will stop this video, and I'll pick it up next time. So see it until then. Bye-bye.